So we've discussed the fact that just because you have a double angle or some multiple of x showing up in a trig equation, that does not necessarily mean that you need to use the double angle formula. And the same would apply if you have a half angle or any multiple of x showing up. If you have just one angle and just one trig function, there's no need to use a double angle or a half angle formula to try to simplify things. But there are times when we do need to use those identities, and basically they're going to be when we have either two different angles showing up in a problem or two different trig functions, and we're not able to separate those into distinct factors. So here, the only trig function I've got is cosine, but you'll notice here the angle is x, and here the angle is 2x. So with two different angles, I'm going to need to use a trig identity. I want to try to rewrite this using just one angle, and generally it's easier to make that angle x. So I'm going to use a double angle formula for cosine. I'm also hoping to write it in terms of just one trig function. So that's going to tell me which version of the double angle formula for cosine to use. Okay. And I forgot to write the directions up here, but we're going to find all solutions in the interval from 0 to 2 pi, and then we'll find all solutions. So the usual directions for solving trig equations here. Okay, so looking at cosine of 2x, I know that that's cosine squared x minus sine squared x. That's the version of the double angle formula that falls out directly from the sum formula. Now, I can see I've already got some cosines, so let's try to get rid of those signs. So I'm going to say this is cosine squared x minus the quantity 1 minus cosine squared x. And if I distribute that negative, this is cosine squared x minus 1 plus cosine squared x. That's going to be 2 cosine squared x minus 1. So I'm going to replace the cosine 2x here with 2 cosine squared x minus 1, and then minus cosine x equals 0. So this right here is equivalent to cosine of 2x. Now I'm going to just switch the order of these to get things in standard form. Usually we have the squared term, then the linear term of, in this case, cosine, and then just the constant. So I'm going to rewrite this as 2 cosine squared x minus cosine x minus 1 equals 0. That's a quadratic in cosine of x. So now I've got just one angle x and just one trig function cosine. This is looking good. I'm going to try to factor. Okay, and in order to get 2 cosine squared, I need to have 2 cosine x and a cosine of x. I can see in order to get a 1, it's going to have to be a 1 and a 1. But in order to make it negative 1, I need one positive and one negative. So let's see. If I want to end up with a negative cosine x, I'm going to want the negative here. That gives me negative 2 cosine x, and a positive there gives me plus 1 cosine x, so that they combine to give me negative cosine of x. So now, two things multiply to give me 0. One of them must be 0. So 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. This would mean cosine of x is negative 1/2. Just subtract over the 1 and divide by 2. And this would mean cosine of x is equal to 1. Okay. So let's see, let's solve that first one first. If I'm looking for cosine of x equaling negative 1/2. No solution in quadrant 1 because cosine's positive there, but there definitely would be a solution here in quadrant 2, and definitely a solution here in quadrant 3 because that's where cosine of x is negative. No solution in quadrant 4 because cosine would be positive there. Both of these are going to have the same reference angle alpha. What I know about alpha is that cosine of alpha will be the absolute value of negative 1/2, which is just 1/2. So, looking at my 30, 60, 90, 1, 2, root 3. The angle whose cosine is 1/2, the acute angle whose cosine is 1/2, is 60 degrees, or pi over 3. So here, x is pi minus pi over 3. That would be 3 pi over 3 minus pi over 3, so that's 2 pi over 3. And here, x would be pi plus pi over 3, because we're rotating past pi. So that's 3 pi over 3 plus pi over 3. That's going to be 4 pi over 3. So far, I've got 2 pi over 3 and 4 pi over 3. And those were just my solutions to this equation corresponding to this factor equaling 0. Now I need to look at this equation corresponding to my second factor equaling 0. You'll notice, though, because we used our trig identity to get everything written as just a function of x, I'm going directly to what x is. If we don't write everything in terms of x, if I had everything, if this had been cosine of, let's say, if both of these pieces had been in terms of 2x, I would have solved for 2x, and then I would have had to divide by 2 to solve for x. Here, though, we rewrote everything in terms of x, so we're going right to what x is. All right, so if cosine of x is equal to 1, now I'm recognizing that that's going to give me a quadrantal angle. There's only one point on the unit circle where cosine is 1. That's this point right here, and that's going to correspond to x being 0. Now, it also corresponds to 2 pi, but here, this was a bracket around 0 and a parentheses around 2 pi, so we're not including that. We'll get 2 pi when we list all solutions, because we'll be adding a multiple of 2 pi to each of these. So all solutions would just be 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, and 0 plus 2 pi n, where n is an integer. And of course, it's not actually necessary to write the 0 plus, so I'm going to just simplify that to be just 2 pi n. Notice if n is 0, that's going to give me back my original solution of 0.